Hello friends, my name is Shubham Katole and today we are going to discuss aptitude problems on very important topic boats and stream. So there are some important formulas before solving the aptitude problems on boat and stream. Downstream and upstream. If your boat is in a direction of stream, then it's called as a downstream. But if your boat is opposite direction of stream, then it's called as the upstream. So if the speed of the boat in a downstream is u kilometer per hour and the speed of the stream is v kilometer per hour, then the speed of the downstream is equals to u plus v kilometer per hour, and the speed of the upstream equals to u minus v kilometer per hour. If the speed of the downstream is a kilometer per hour and the speed of the upstream is b kilometer per hour, then the speed in a still water, then the speed of the boat in a still water equals to half of a plus b kilometer per hour, and the rate of the stream equals to half of a minus b kilometer per hour. Guys, learn this formula because without these formulas you can't solve the problem of boat and stream. So learn it and mug up it. Moving toward the first problem, a boat can travel with a speed of 13 km per hour in a still water. If the speed of the boat stream is 4 km per hour, find the time taken by a boat to go 68 km downstream. Here the given that the speed of the boat in a speed of the boat is 13 km per hour in a still water and the speed of the stream is 4 km per hour. Always try to find the given data and then try to solve it. So we have to find that speed of the boat in a downstream. Speed of the boat in a downstream is nothing but the addition of speed of the boat and the speed of the stream. So 13 plus 14, 4 equals to 17 km per hour, and we have to find the time taken by the boat to go downward, to go 64 km in a downward. So we have to simply use the formula speed is equal to distance upon time, but we have to calculate time, so that's why the formula is like that, time equals to distance upon speed. So distance is 68 km and the speed equals to 17 km per hour. So the time required to go in a downstream equals to 4 hours. Next problem, a motorboat whose speed is 15 km per hour in a still water goes 30 km downwards and come back in a total time of 4 hours 30 minutes. The speed of the stream is, the given data is the speed of the motorboat in a still water is 15 km per hour. So let's consider the speed of the stream is x. So obviously when we calculate the speed of the downwards is nothing but the addition of speed of your boat and speed of stream. So the speed of the downwards is equal to 15 plus x kilometer and the speed of upstream equals to 15 minus x kilometer per hour. The given that it takes 4 hours 30 minutes to go downwards as well as upwards. So 4 hours 30 minutes is nothing but the total time required to go downward and upward. We have to simply use the formula speed is equal to distance upon time, where we know the time and distance equals to 30 km is downward and 30 km as upward. So apply 30 km by divided by 15 plus x is nothing but the speed of the downwards plus 13 divided by 15 minus x equals to 4 multiplied by half. So when we simply make the cross multiplication, we get the value of x is nothing but the 4 km per hour and is nothing but the speed of the stream. Next problem, in 1 hour a boat goes 11 km along a stream and 5 km against the stream. The speed of the boat in a stream water. Simply in this problem we have to calculate the speed of the boat in a still water. Let's consider the given data. The boat goes 11 km along the stream and 5 km against the stream. Simply use the formula speed in a still water is equal to half of A plus B. A is nothing but the 11 km per hour and B is nothing but the 5 km per hour. So when we solve this calculation, we get the value 8 km per hour. So the speed of the boat in a still water is 8 km per hour. Next problem. A boat running downstream covers a distance of 16 km in 2 hours, while for covering the same distance upward it takes 4 hours. What is the speed of the boat in a still water? Given that a boat goes downward, covers a distance 16 km in 2 hours, it means the speed of the boat in a downstream is equals to 16 by 2 equals to 8 km per hour, and the same distance can covered in upstream within 4 hours. So rate of the, or we can say that the speed of the upstream equals to 16 by 4 equals to 4 km. We have to calculate the speed of the boat in a still water. Simply we have to use the formula speed in a still water equals to half of A plus B. So A is nothing but the 8, that is downward, and B is nothing but the 4, that is upward. So when we make the calculation, we get the answer 6 km per hour. Next problem. A man can row at 5 km per hour in a still water if the velocity of the water is 1 km per hour and it takes him 1 hour to row up and come back. So how far this place is? In that situation, the given that a man row at 5 km per hour in a still water and the velocity of the current is 1 km. The given that the speed in a still water is 5 km per hour and the velocity of that stream is 1 km. So simply the speed of the downwards is 5 plus 1 6 km, and the speed of the upward is 5 minus 1 equals to 4 km. Given that it takes 1 hour to go downwards and upwards takes 1 hour. So that's why we consider the overall distance as x. So we simply use the formula speed is equal to distance upon time. Speed is nothing but the downstream and the upstream, and the time equals to 1 hour. So x by 6 plus x by 4 equals to 1. Make the cross multiplications and we get the answer x equals to 2.4, that is nothing but the distance. If you like my videos and if you want to watch my another videos, do not forget to subscribe and like my channel. Thank you guys. Thank you for watching my videos. Thank you.